So welcome to the second block of our course, where we are going to talk about inference, meaning how to use the knowledge about your sample and extrapolate this knowledge to the whole population. We will start with confidence intervals. It's one of the ways to make inference. And then later on the second lecture, we will also talk about hypothesis testing. So that's the first lecture. It's going to be quite long. We will talk about different confidence intervals, different distributions. And at the end of this lecture, you will learn how to calculate these confidence intervals, at least for three statistics. It's a proportion, it's average value, and the variance. So let me remind you quickly what we are talking about, meaning samples and populations. We, first of all, are interested in population. Population is a set of all objects you want to investigate. For example, if you want to invest in new medicine, population is all patients in this world who have a certain disease you want to cure. Okay. Most of the time you can't work with the whole population because it's time consuming, it can be huge, it can be impossible simply. So what you want to do, you want to take a sample, which is a small part of your population, and then using sample to see if you have any systematic effects, for example, if your medicine works correctly. And then the sample consists of individuals. We can call them objects or measurements. It's every single object in your sample. For example, it can be a patient, a glass of water, a piece of metal, or anything else. Okay. And then when we do the measurements for our individuals, we collect the data. So by doing measurements, by measuring some parameters, we collect the data, and that's what we have. We have some values for a given sample, but not for the population. Okay. Well, we should remember that the way we take a sample is very important. All statistical methods work only if your sample is random and representative. Random means that it was taken randomly from the population. So if you think about all objects your population consists of, every object should have a same chance to get to be chosen as a sample. Okay, and then representative, it means that the sample should be big enough to cover the whole population. You can think about that representativity is that the statistics of your sample are very close to the parameters of your population. Okay. For example, if you flip your coin 3 times and get 3 heads, this sample is not representative because it doesn't tell you that actually there is another outcome that is possible in your population, which is a tail. Okay. So it's very important that when you take your sample, it should be random and representative. Only in this case, all statistical methods will work correctly. Now, I'll just remind you again some notation. So with the population, we use capital N and Greek letters for parameters of this population. And then when we talk about sample, we use small n for the sample size, and the statistics or characteristics of the sample are denoted by Latin letters. For example, if you talk about average, for the population, it's a parameter, and we call it mu. And then if we talk about a sample, it's a statistical characteristic of the sample, and then we call it m. So the problem is that we are interested in mu, but we have only m. So is it possible to estimate the parameter of population using statistics of your sample? Okay. And then that's the normal procedure. The first step is sampling, is when you take a sample. And then the second step is the description of your sample. So you describe your sample, you describe what's going on with your sample, you look at the distribution, you calculate different statistics, everything that we have learned in the first block. And now it's time to learn how to make the third step, which is an inference. So when you use the statistics calculated for your sample and try to estimate parameters for your population. So you generalize the knowledge about your sample to the whole population. Okay. That's the data set we are going to use in these 2 lectures at least. It's 10 glasses of water from 2 different rivers. These are rivers from the southern Jutland part. One is called Ribe. It's situated not far from the oldest Danish city, which is called Ribe, and one is called Wade. It's not a big river, it's small. They all look like streams, but anyway. Okay, so let's pretend that we took 10 glasses of water from every river, and we did it in a correct way. So these 10 glasses of water represents the river, and then they were taken randomly. And then we measure it, how much of chloride we have in each glass, and then you can see that we have pretty different random values for each of the river. the question is, well, these are some questions actually I have written down. Well, first of all, what is average content of chloride in both rivers, or in each river? Then can we say that average content in rivers is below 146? Let's say that 146 is the maximum allowed concentration of chloride in the river. Then the third question, can we say that this content is different? For example, in Vada we have more chloride than in Riba, so Vada is more contaminated than Riba, or vice versa. Okay. What can we do? Well, the first step is, of course, taking the sample, and we have already the sample, we have already the data values. So the second step is to calculate different statistics that describe your sample. So these are statistics. So the mean chloride content in Vada is 152 milligrams per liter. And the mean chloride content in Riba is 139 milligrams per liter. And the standard deviation, you see, they are pretty close to each other. It's about 10. Okay. Does that mean that average chloride content is different? Can we say that Vada is more contaminated than Riba? Well, if you look at these values, it seems to be so. Okay. But in fact, it's not. Because what do we have here? It's statistic of our sample. It doesn't mean that for the whole population, this will be the same. So when you deal with your sample, you can't just simply extrapolate these statistics to the whole population. You have to do it in a different way. Okay. So now we can assume what's the goal of this block. Okay. The goal is to learn how to make an inference, meaning you have a population. And then this population have different parameters. So if you assume, for example, that population values in the population are distributed normally, of course the parameters are, first of all, it's mu and sigma. Or you can think about variance sigma squared. Okay. Then we have a sample. So the sample of size n. And we have some statistics calculated for the sample. The average, the standard deviation, the variance, and so on. Okay. The point is, okay, we have this statistics, so we have M, S, and N, okay? Can we use these statistics to get a knowledge about a parameter, let's say the average chloride content in a population, okay? So this is an inference, so you try to estimate the parameters of your population by using statistics of your sample. So here we have parameters, and here we have statistics. Okay. And this procedure, when you try to estimate parameters of the whole population using statistics of your sample, this is what is called inference. And the methods we are going to use are called inferential statistics, or methods for inferential statistics. Let's start with one of these methods, which is called confidence interval.